So today I will start this next topic, that is nothing but Boolean algebra. Okay, so what is this Boolean algebra? So Boolean algebra, there is a scientist called Boole. He given some laws. Okay, so that's why we call as Boolean algebra. Some laws. So you have so this is Boolean algebra. Uh, Boolean algebra. I think my screen is visible now. Give a response. Yeah, my screen is visible now. Give response. Hello. Yes. Anyone? Okay. I think my screen is visible. Okay. 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 Yeah. So we'll see the Boolean algebra. So Boolean algebra first is we call as so this is first law, that is nothing but and law. Okay. First law is nothing but we have and law. Okay. We have and law. I will see this and law. Close this. First law is nothing but so by using and we have and law. Mm, so you take the and law. We'll change the. So so you have you know the and gate. Okay, you know the and gate. So what is the and gate? You have A, B, and what is the output? Output. So if any one of the input is low, the output is low. Any one of the input is low, the output is low. Okay. So here you have 0, 0, and here 0 and 1 you have getting. Okay. So that means if you see like first A and A. Okay. That is equal to what? A. Okay. A and A equal to what? A. So how we are getting? You take this one. A is 0 and A is 1. Okay. So that means this case, this is the first case. Okay. So that is nothing but 0 and 0 equal to what? 0. And 1 equal to what? 1. Okay. So that means 0 and 0. So whatever the A value is there, that you are getting same value. 1 and 1. You are getting same value. A and A equal to A. Okay. And next if you see A and 0 equal to what? 0. Okay. A and 0 equal to 0 means you take this first case and A and 0. Okay. This third case. Okay. This is second one. Okay. Second one if you see A and so that means A is 0. A is 0. 0 with 0. Okay. You are getting what? 0. Suppose A is 1. 1 with 0. What you are getting? 0. Okay. So that is second law, and third law is if you take A and 1 equal to what? A you are getting. Okay. A and 1 equal to A means if you see A is 0, so A and 1 you are getting, so this one and this one. Third one you see. So third one from the truth table I am proving. So that is 0 and 1. So A is 0. Okay. And with 1, what you are getting? A itself. Okay. Suppose A is 1. Okay. A is 1 and with 1. Okay. And with 1 you are getting A itself. Okay. So A and 1 equal to what you are getting? A itself. Okay. And fourth one, if you see A and A bar equal to what? 0. Okay. A and A bar equal to 0. Suppose if you take this case, A is this one, this. Okay. This is fourth one. A is 0 with the complement, that is 1 equal to what you are getting? 0. A is 1 with that complement 0, what you are getting? 0. Okay. So this is nothing but and law. Okay. So this and law is clear. Anyone? Give in the chat box. Uh, is and law is clear, no? Just clear now? Yeah. So that I will move forward. Okay. And next you see, anyone? Anyone? Give in the chat box. Is this analyze clear now? Yeah. I'm waiting for your response. Okay. Next you see. Next is nothing but what? Arla. Okay. So next is nothing but Arla. Okay. This is last slide. 1 second. I need to copy. Control X. And here. So yeah. So this is nothing but AND law. And next you have what Arla. Okay. So next you have Arla. So R gate. So R gate I am drawing. So R gate I am drawing. So if you see, this is R gate. OR gate. First, I will draw the truth table for OR gate. So that means if you define OR gate with one statement, so that means any one of the input is 1, the output is 1. Okay, any one of the input is 1, the output is 1. So this is nothing but 0, 0, 0, 1, and next 1, 0, and 1, 1. Okay, 1, 1. So see here. So that means if any one of the input is 1, the output is 1. The output is 1. Okay, so I'm seeing this. So first law. So this is nothing but ARA equal to what? First law. ARA equal to what? A itself. Okay, ARA equal to A itself. So that means here if you see, so ARA equal to A itself means this is A equal to 0, that and same value. Okay, this is first law. Okay, this is first law. So if you see 0 or 0 equal to what, you are getting A itself, this 0 itself. Okay, and 1, A is 1 with same value A, you are getting 1. Okay, 1 or 1 equal to 1. Okay, this is first law. And second law, you see, second law, A or 0. Okay, A or 0 equal to what, you are getting A itself. Okay, so A or 0 means this one, and this one. Okay, so first and third you see. Okay, first and third, A is 0, R with 0. Okay, you are getting A itself, whatever the A value is there, you are getting same thing. Suppose A is 1. Okay, A is 1, R with 0. Okay, what you are getting? 1. Okay, you are getting the same value, whatever the value is there, you are getting the same value. Okay, and third case you see. Okay, so third case, A R1, AR1 equal to what? 1. Okay, so AR1 equal to 1 means so this one and this one you see. Okay, so this one and this one. Okay, this is third one. So you see, so that is nothing but 0 or 1 equal to what? 1, or 1 or 1, that is equal to what? 1 you are getting. Okay, so that is nothing but AR1 equal to 1. And next is AR A bar complement of R gate. This is equal to what? 1 you are getting. Okay, so AR A bar equal to 1 means this one, second one, and third one. Second one and third one. Okay, this is fourth law. Okay, so if you take A0, complement of this one is 1, you are getting 1 itself. If you take A1, complement of 0, so 1 is 0, you are getting 1 itself. Okay, so this is nothing but R law. Okay, so that means if you apply dual for this one, you will get R law. Okay, so dual means what? Duality means changing duality. Here also I'll tell you the duality. Duality means what? Changing R to and and to R, and to R. Okay, and to R, and changing zeros to ones, and 1 to 0, and 1 to 0, 1 to 0. So see here, so if you apply duality, so here with one other color, so if you see here, so if you apply duality for this one, I'll get first law. So this is ARA equal to what? A. Okay, and next changing zeros to ones and ones to zeros now. So this is nothing but AR1 equal to what? 1. Okay, I will get second law. And next this one, AR0 equal to what? A. Okay, Here what I will get, a or a bar equal to what, 1. Okay, so if you apply the duality, you will get this law. Okay, this laws. Okay, so this is about the R law and law. So if you apply duality for the here also, so see here, a and a equal to what, a, and this one a and 1 equal to a, and here a and 0 equal to 0. You'll change ones to zeros and zeros to ones. A and a bar equal to what, 0. Okay, you will get a and law. Okay, so this is about and law and R law. I think you understood. Any doubts in this? Yeah. Any doubts in this? Give in the chat box. Give the message in the chat box. Are you available? Are you there? Yeah. Shall I move forward? Give response. Anyone? Hello. Yes. Okay. Next you see. So next, I'm using not law. Okay. What is this not law? What I'm using not law. One second. Not law. Yeah. Not law is nothing but what? Not gate. I'm using not gate. So from not gate I will get the not law. So that is nothing but a, and output is y. Okay, output is y. So if it is 0 I am getting 1. If it is 1 I am getting 0. Okay, so that means a bar whole bar, this is equal to what, a I am getting. Okay, a bar whole bar equal to a I am getting. Okay, that is nothing but not law. Complement of complement is nothing but true form I am getting. Okay, so that is not law. And next is commutative law. Commutative law. So commutative law is nothing but what? Commutative law is so A or B equal to what? B or A. A or B equal to B or A, and A and B. A and B equal to what? If you apply duality, B and A. A and B equal to B and A. That is commutative law. Okay. And next is associative law. Associative law. So associative law is nothing but so one second. The recording is done. Okay. Yeah. So next is associative law. So what is this associative law? Associative law means you can consider this is same. This is nothing but what? Same. Okay. Associative law is nothing but you can consider as same. So how we can write the associative law means, here if you see, so A R A R B B R C. Okay, A R B R C equal to what? A R B R C equal to A R B R C. A R B R C. Okay, and if you apply duality, A and B and C equal to what? A and B, and next and C. Okay, so here all are same. See here, all are R gates are there. Just bracket is different. Okay, here I am keeping bracket here. Okay, so here also, so and all are same. See here, and all are same. Okay, this is nothing but associative law. Okay, and next distributive law. So what is distributive law? Distributive law is nothing but you can remember like difference. This is difference. Okay, different. This is nothing but different. Okay, so here you have A and B or C. A and B are C equal to what? A and B or A and C. A and B or A and C. So that means here AND gate is there and here OR gate is there. Okay. And here what will be there? Here two AND gates in a difference is there. Okay. So that is AND gate, OR gate is there. Okay. And duality you have apply and will change to R no. AR B and C. Okay. AR B and C. That is equal to what? ARB and ARC. A and B and ARC. Okay, so this is one of the important property, distributive property, and from the distributive property you will get absorption law. Absorption law. So what is this absorption law? So suppose if you take AR A bar B, AR A bar B. Okay, so like by using this I am applying in place of B you have A bar. Okay, I am applying, that is nothing but AR A bar, AR A bar, and next AR B. Okay, AR B. So you know that from R law. So this is nothing but what? 1 1 A or B. Okay, so this is nothing but from AND law, A and 1 equal to A, so you are getting A or B. A or B. Okay, so this is nothing but absorption law. You have true form and complemented form. This complemented form becomes redundant. Okay, and similarly you see here, so this is A bar plus AB. So this is equal to what? A bar plus A. I am applying distributive law. A bar plus B. Okay. So this is equal to what? 1 and A bar plus B. Okay. 1 and A bar plus B. From AND law, you have A bar plus B. These laws are clear, no? So that till a distributive law. Okay. So till distributive law, I think, hope these are clear. Okay. Yeah. Okay. Next. Next you see. Next laws. Yes. Next class, there is a De Morgan's law. Okay. There is a De Morgan's law. What is this De Morgan's law? De Morgan's law. So De Morgan's law is nothing but here. So De Morgan's law. We'll see De Morgan's law. So De Morgan's law. So this is nothing but A or B whole bar equal to what? A bar and B bar. Okay, A bar and B bar. So that means R along with the complement will come to each and every literal, and so R will change to and. Okay, R will change to and. Okay, this is first law. And second law you see, so A and B whole bar, this is equal to what? A bar or B bar. Okay, this is second law. So that means and complement will come to each and every literal and will change to R. Okay, so that means from this you can say the equality of gates. So that is nothing but this is nothing but what? NOR gate. This is nothing but NOR gate. So A B, so here you are getting ARB whole bar. ARB whole bar, this is nothing but NOR gate. This is equivalent to what? Bubbled. NOR gate is equivalent to bubbled and. Here this is nothing but A, B, this is nothing but A bar, B bar. Okay, so this is nothing but bubbled and, bubbled and. Okay, and similarly NAND gate, NAND gate. Okay, NAND gate equal to what? This is A, B, Y equal to what? Y equal to A, B whole bar. Okay, so NAND gate is equivalent to bubbled or. NAND gate is equivalent to bubbled R. So here A, B. So here you are getting A bar plus B bar. A bar plus B bar. Okay. So this is about. So priority means. So if you see the priority. So if you see the priority, not is having the highest priority, and next and next or. Okay. So not is having the highest priority, and or is having the lowest priority. So these are the rules. Okay, these are the rules. Okay, so that means so if you write the rules, Boolean algebra rules. So here I am writing in the answer what are these rules. Okay, Boolean algebra rules. Boolean algebra rules. If I write, so what I will get? So first is not. Not we already seen, no? So not is nothing but what? A bar whole bar, that is equal to what? A. Okay, and next you have and what is this? And A and A equal to what? A. And next A and 0 equal to 0, A and 1 equal to A, and next A and complement, A bar equal to what? 0. Okay, 0. And next you have R. Okay, R law. So what is this R law? A equal to A, and AR0 equal to A, and AR1 equal to 1, AR A bar. Okay, AR A bar equal to AR A bar equal to 1. Okay, AR A bar equal to 1. Okay, and next you have what we discussed, associative law, no? Associative law. So what is this associative law? So that means A or B or C. equal to what? A or B or C. Okay, and next A duality, A and B and C equal to what? A and B and C. Okay, and next you have distributive law. Distributive law. So distributive law is nothing but what? Distributive law is A or B C equal to what? Difference A R B and A R C. Okay, and next dual A and B R C equal to what? A and B or A and C. Okay, and next absorption law. So from the distributive law you will get absorption law. What is that absorption law? A bar B equal to what? A R B. Okay, that is the redundant. This complement is the redundant. A bar or A B equal to what? A bar or B. A bar or B. Okay, and next you have De Morgan's law. De Morgan's law. So there are two laws are there. One is A or B whole bar equal to what? A bar and B bar, and second one A B whole bar equal to what? A bar or B bar. Okay, A bar or B bar. So these are the laws. Okay, and next you have, these are the basic summary of the laws. Okay, so next I think hope you understood this all these laws. Okay, anyone? Yeah, shall I move forward? Yes. So okay, no. Yes, okay. Next you see. So next there is a consensus theorem. What is this consensus theorem? Consensus theorem. Consensus theorem. So consensus theorem is nothing but so if you see so the consensus theorem. So theorem one. Theorem one. Okay. So what is the theorem one? AB plus A bar C plus BC. This is equal to what? AB plus A bar C. So here what happens? That means here, so one term A is in true form and complemented form in two terms, and B is repeated in third term. So this becomes the redundant. This is nothing but this will be eliminated. Okay. So how we will prove this consensus theorem? So I am taking the LHS. I am taking the LHS. So here AB plus A bar C plus BC I am taking. Okay, so this is equal to what? So that means here I am writing BC and 1. Okay, and 1 can I write? Okay, why? Because from this and law I know that A and 1 equal to what? A. Okay, and next what I am writing? AB plus A bar C plus this BC. I can write this one as what? A plus A bar. A plus A bar. Why? Because from R law, you know that A plus A bar equal to what? 1. Okay. So AB plus A bar C plus ABC plus A bar BC. Okay. A bar BC. So from these two, what I can take common? I can take AB common. Okay, AB if you take common, I am getting 1 plus C. And if I take A bar C common, what I am getting? 1 plus C. Okay, so this is nothing but AB 1 plus, from R law, you know that AR1 equal to what? 1, no? So this is 1 and A bar C and 1. Okay, from AND law, you know that A and 1 equal to what? A. So this is nothing but AB plus A bar C. AB plus A bar C. Okay. So what is dual of this one? Dual you need to prove. Okay. That is your task. Okay. So dual task. You need to prove the dual of this function. Okay. So what is this? This is nothing but ARB and A bar RC or BRC. That is equal to what? ARB and A bar RC. This is the dual of consensus theorem. Okay, so this is the dual of consensus theorem. That proof you need to prove. Okay, so by using this Boolean algebra, so you need to do some problems. Okay, so using, I think this is clear, no? Consensus theorem. Okay, so I think this is clear. Okay. Yeah. Anyone? Your response? Consensus theorem? Yes. Shall I move forward? Yeah. Okay. Next you see. So next, so by using this Boolean laws, I'm doing some problems. Okay, Boolean algebra problems. Okay, if you see Boolean algebra problems. Okay, so here what I am doing, just take this problem like first one. If you take first one, AB whole bar plus A bar plus AB whole bar. Okay, so this I need to solve this. I need to minimize the given equation into minimum number of literals. Okay, so here what I can do, I can consider AB as what? AB as x. Okay, AB as x. Okay, I can consider AB as x. Okay, so let us take x equal to what? AB. X equal to AB. AB. So I'm taking x equal to AB means what I'm getting? X bar plus A bar plus AB plus x. AB is x, no? So this is whole bar. Okay. So we know that. So this is x bar. This is x. We know that from R and R law, A bar equal to what? 1, no? So this is 1 plus A bar. Okay, whole bar. So from R law, you know that AR1 equal to what? 1. So this is nothing but 1 bar. So 1 bar equal to what? 0. 1 bar equal to 0. Okay, so this is one method. Other method is normally you do. So you apply De Morgan's law. So what is my problem? So this is nothing but AB bar plus A bar plus AB. Okay, so this is I am apply De Morgan's law. So AB bar whole bar, R will change to and, no? A bar whole bar and AB bar. Okay, AB bar. Okay, so this is nothing but what? AB, and this is A and AB bar. AB bar. Okay, so AB and AB, so that means you know that from AND law, A and A equal to what? A, no? So I can write this is nothing but AB and AB bar. Okay, from AND law you know that A and A bar equal to what? 0, no? So this is nothing but total value 0. Okay, here 0, here 0. So like this you can do, or you can do this one also correct. Okay, so I think this problem is clear. Okay, it's clear, no? Yeah, anyone? Okay, next, next you see. Next, I'm taking this value. Mm, one second. Okay, so second one, uh, AB bar CR BD plus A bar B bar. Okay, A bar B bar. So simplify the equation into minimum number of literals. Okay, so this is nothing but what? AB bar C plus, so you multiply AB bar B T plus A bar B bar. Okay, so you know that A and A bar equal to what? 0, no? So this one is nothing but 0. This is 0. Okay, so A B bar C plus 0 plus A bar B bar. Okay, so now you know that AR0 equal to what? A, no? So this I can write as A B bar C plus A bar B bar. Okay, so this is nothing but B bar if you take common. So this is nothing but uh, so AC plus A bar. AC plus A bar. So from the absorption law, you know that A bar plus AB. Okay, here true form and here complemented form. So I can write this one as A bar plus B. Okay, so this is nothing but B bar. Okay, A bar plus C. A bar plus C. So like this I can. Okay, so I think it's clear now, this problem. Yeah, it's clear, no? Anyone? Okay. So next problem, I will move forward. Yeah, I will move forward. See here. Mm, Third one. ABC whole bar, AR, BRC whole bar. Okay, whole bar. So how I can do this one? So how I can do this one? So just apply De Morgan's law. So we know that De Morgan's law, that is nothing but what? AB whole bar equal to what? A bar plus B bar, and ARB whole bar equal to what? A bar B bar. Okay. So this apply De Morgan's law. So this is nothing but A bar plus B bar plus C bar. Okay. And this one is nothing but ABC whole bar, ABC whole bar. Okay. Next you multiply. So that means here A bar, A, one second, one second. Here what you will get, here what you will get, here this will be coming to each and every literal, no? Okay. Yeah. So this is nothing but what? A bar, B bar, C bar. Okay. So if you multiply, this is nothing but A bar, B bar, C bar plus B bar, A bar, B bar, C bar plus C bar, A bar, B bar, C bar. Okay. So you know that from AND law, you know that A and A equal to what? A, no? So that means this one I can write as A bar, B bar, C bar plus A bar, B bar, C bar plus A bar, B bar, C bar. Okay. From AND R law, you know that A or A equal to what? A. Okay. So all this I can write as A bar, B bar, C bar. A bar, B bar, C bar. This is nothing but you are minimizing the given expression into minimum number of variables. Okay. So this is fourth one. Okay. And third one and fourth one you see. Fourth one. Fourth one. AR, AR, B bar C, B bar C, and next AR, AR, B bar C whole bar, B bar C whole bar. Okay. So first what you need to do? First not highest priority is not, no. So that means whatever the not is there. So we already see highest priority. First not, next and next last priority is R. Okay. So this is highest to lowest priority you'll get. So whatever the variables that there is a not, you need to apply. So you know the De Morgan's law. You need to apply the De Morgan's law. AB bar equal to what? A bar plus B bar. You need to apply the De Morgan's law. So here I am applying. So this is nothing but what? A bar, B bar, C. And this one is nothing but about A bar, B bar whole bar plus C bar. B bar whole bar plus C bar. So AR, B bar, C. So this is nothing but what? AR, B R C bar. B R C bar. Okay. And next you multiply. Next you multiply. One second. Yeah. Next you this one. AR, B bar. Here you will get A, no? You get A. Okay. A, B bar, C plus B bar, C, B plus B bar, C, C bar. Okay. So from this you know that A and A bar equal to what? 0, no? So this becomes what? This becomes 0 and this becomes 0. Okay. So here you will get AR, A, B bar, C plus 0 plus 0. Okay. So this is nothing but AR, A, B bar, C. Okay. AR 0 equal to 0, no? AR equal to A. A. Okay. So next from this you take A common, 1 plus B bar C. Okay. So this is nothing but what? A and 1. This is equal to A. Okay. So why? Because AR1 equal to what? 1. AR1 equal to 1. Okay. So like this. Okay. Like this you need to do. Okay. Is it fine? Anyone? Give response. Hello. Yes. Shall I move forward? Okay. I think you understood this problem. Okay. And next you see. So next problem. Next problem you see. So next problem. If let us take if x equal to 1, then then x plus z y bar plus xy bar xy bar, okay, and x bar plus z bar x plus y, x plus y, that is equal to what? 1. Okay, so what is the value of z? Okay, what is the value of z? Okay, z value you need to find out. Okay, so how to find out here? If you see, that means so this is my expression. So what is my expression? X plus z y bar uh, plus uh, z bar plus xy bar uh, xy bar and x bar plus z x bar plus z bar and x plus y, that is equal to what? 1, no? So you replace x equal to 1, so 1 plus 1 plus z 1 plus z y bar plus z bar plus 1 into y bar, 1 into y bar, and next 1 into y bar, mm, x bar means 1 bar means 0 plus z bar, and this is nothing but 1 plus y, 1 plus y, x equal to 1, no? So next, so that means if it is 1, suppose if you consider this whole value is a, you know that from R law, whatever may be that value, that whole value becomes what? 1. Okay, AR1 equal to 1, 1, 1, and next this one is nothing but this is anyway 1. Okay, and here so z bar plus 0 equal to what? Z bar itself. Okay, so here you are getting z bar, that is equal to 1. So z bar equal to 1, z equal to 0, z equal to 0 you'll get. Okay, so like this I need to do. Okay, so z equal to, that value is z equal to 0. Okay, and next if you see, so next problem we'll see, we have a three variables, we have a three variables. Let us take a, b and c. Okay, find find output that is y equal to 1 for majority of 1, for majority of 1. Okay, majority of 1 in abc. Okay, also minimize the function, also minimize the function, minimize the function. So that means if majority of ones are there, means the output is 1. Okay, let us take three variables are there. So three variables means how many combinations you will get? 8 combinations you will get. Okay, so like so 8 combinations: 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, and 1 1 0, and 1 1 1. Okay, so if you see the majority, so here only 1 1 is there, means the output is 0. At least two ones are 0 means the output is 1. Okay, so two ones are there means the output is 1. Okay, so if you write for this one, this one, this one, and this one. Okay, so what you will get? Y equal to this one a bar bc plus a b bar c plus abc bar plus abc. Okay, so from these two I can take ab common, no, I can take ab common. So a bar bc plus a b bar c. If I take ab common, what I am getting? C bar plus c bar plus c. Okay, and next a bar bc plus a b bar c plus this one is nothing but ab and 1. Okay, ab and 1, and from these two you take a common. Okay, what I am getting? A bar bc plus, if you take a common, b bar c plus b. Okay, b bar c plus b. So you know that this absorption law, a plus a bar b equal to what? A r b, no, a r b. So that means here this is the redundant. Okay, so this is nothing but what? A bar bc plus a, next b bar, b bar is the redundant. Here you are getting c plus b, c plus b. Okay, and here if you write, so this is a bar bc plus b plus c, ac plus bc. Okay, ac plus bc, ac plus ab, ac plus ab. Okay, and if you take from these two, if you take b common, what you are getting? This is nothing but a bar c plus a plus ac. Okay, so this is equal to what? This is equal to, again apply absorption law. So true form and complemented form. Complemented form is the redundant. So here you are getting a plus c plus ac. So if you multiply, what you are getting? ab plus bc plus ac, ab plus bc plus ac. Okay, so like this you need to do. Okay, and next this is about Boolean algebra. I told, means forgot to told this binary codes. So what are these binary codes? We'll see. Okay, what are these binary codes? We'll see this. Okay, so binary codes. Next binary, what are these binary codes? Okay, so this Boolean algebra is fine, no? Any doubts in this? It's Boolean algebra is fine. Okay, yeah, anyone? Yeah, someone is responding. Your response? Any doubt in this?
Sir, in the sentence actually, sir.
This one,
Yes, sir.
yeah, tell me.
B plus B bar C అంటే B bar C plus D అంటే B plus C అనుకుంటా కదా సార్.
Where you are telling?
లాస్ట్ థర్డ్ స్టెప్స్.
Last, from last is third step. Okay, this is nothing but here applied. This is nothing but what? A plus a bar b. This is equal to what? A r b, no, absorption law I told you. So that means this is true form. This is complemented form. What is the redundant? Complemented form is the redundant, no? So you are getting what? C plus b,
You wrote C bar, no sir, that's why.
not c bar. This is c plus b only. Just this is c plus b. Okay, this is c plus b only. Okay, this is c plus b.
Okay.
Yes. Mm, yeah. One more problem is there. Like suppose dual means, I told you, no, you are converting R to and to R, ones to zeros and zeros to ones. Okay. Suppose one problem is there. You want to find out. So this same problem I take. This is nothing but let us take the function f equal to ab plus bc plus AC. Okay, find out AC. Okay, so find this is self dual. What is self dual? Self dual means if you apply the dual of this function, then you will get the same. You should get the same function. Then it is called self dual. Okay, that is nothing but self dual. So what is the self dual? We'll see. Okay, so if you see this one, self dual. So I'm taking this function. What is this? F equal to AB plus BC plus AC. Okay. Apply dual of this function. So what is the dual of this function? Dual equal to what? Changing. So what is the dual? We already seen. Changing, changing, and to R, and to R, R2 and R2 and zeros to ones and ones to zeros, ones to zeros. So here I'm applying. So that means ARB and BRC and ARC. Okay. So here, so that means here I can apply distributive law. From this one I can apply distributive law. So what is the distributive law? ARB, ARB and ARB BRC. What I can write? This is nothing but I can write B is common. BR AC I can write. Okay, BR AC I can write. I am applying distributive law for these two. Okay, so how I can write? This one is nothing but BR AC I can write. And next this is nothing but ARC, and next you multiply. So this is nothing but BA plus BC plus ACA plus ACC. Okay, so this is nothing but if you see, so AA I can write 1A, CC I can write 1C. Why? Because from AND law, A and A equal to what? A. Okay, so this is AB plus BC plus AC plus AC. Okay, from R law I can write as what? ARA equal to what? A. Okay, so this is nothing but what? AB plus BC plus AC. So this is equal to what? F. I calculated FD. Okay, so that means dual of the function. At last what I get? F. Okay, then we can say that this function is nothing but self dual. This function is nothing but self dual. Okay, so this is one more problem related to this Boolean algebra. You need to find out. They will ask the question and like they will ask to find out whether it is self dual or not. Okay. And the next, this binary codes are there. What are these binary codes? So binary codes. First is nothing but weighted code. Weighted code. So what are these weighted code? Weighted codes are nothing but each digit position has a weight. Okay, each digit position have a weight. Have a weight. Suppose if you consider binary code, BCD code. So these are nothing but what we call as 8421, 2421, okay, 2421, 3321. Some codes are there, okay, and 4221. The codes which are having weights are nothing but we call as weighted code. Okay, suppose if you consider 1001 in BCD. Okay, so what is the weight? 8421 means what? 8 plus 0 plus 0 plus 1, that is equal to 9. This is the BCD value for 1001. Okay, this is weighted code. And next is non-weighted code. Non-weighted code means what? The non-weighted code, there is no positional weight for each digit. Okay, so there is no positional weight for each digit. That is nothing but non-weighted code. Okay, there is no positional weight. Positional weight. Okay, so like you have XS3 code, and gray code. Okay, gray code. So XS3 code means what? Suppose if you take BCD and XS3, BCD and XS3. So here if you see, the range of the BCD is from 0 to 9 only. So that means 0000. So what is the XS3 code? 0011. Okay. If it is 0001, what is the XS3 code? 010. You are adding 3. That is nothing but we call as XS3 code. Okay. So this is 0010, this is 0101, and 0011 means what? 0110. Okay, 3 means 6 you are getting, and 0100 you are getting like 7, and 0101, and you are getting 1000, and next 0110 means 1001 you are getting, and 0111 means you are getting 1010, and 1000 means 1011 you are getting, and 1001 means you are getting 1100. Okay, so they can ask in the interview what are the unused state in XS3. Okay, unused states are nothing but 0, 1, 2, next 13, 14 and 15. These are the unused states. Okay, so that means by using this, by seeing this XS3 code, we can't find the value. There are no weights. Okay, there are no weights. That's why this is nothing but non-weighted code. Okay, non-weighted code. XS3 code is nothing but non-weighted code. Suppose if it is a gray code, 00, 01, 11 and 10, this is 2 bit. By seeing this, I can't find the value for the gray code. Okay, so I can't find the value. That's why this is nothing but non-weighted code. Suppose if it is 3 bit, how I can write the gray code? 00, 01, 11, 10, and here you start from here, 00, 01, 11, 10, and here you keep all zeros. This is 0 and this is 1. This is 1. Okay, so by seeing this, I can't find out that these values. Okay, so that is nothing but we call as weighted code. Okay, this is about the weighted code. And next, third one, you have reflective codes. You have reflective codes. Reflective codes is nothing but what? Reflective codes is uh, the first n by 2 value. Okay, n by 2 value compared with the last n by 2 value. Okay, last n by 2 value. Okay, n by 2 value. Then this is in reverse order. In reverse order. Okay, suppose like 2421 and 5211 and XS3 code. Okay, XS3 is nothing but non-weighted code and reflective code also. So how you can find out this is reflective code? Here I wrote XS3 code, no? So that means here you see, so this first bit and last bit, if you apply ones complement, you will get the last bit. Okay, if you apply ones complement for this second bit and last but one bit, you'll get the last bit. Okay, here also third bit and last third bit, you'll get ones complement. Okay, and fourth bit and last fourth bit. Okay, so that means first bit and last bit, if you, for the first bit if you apply ones complement, you'll get the last bit. Okay, so that's why XS3 code is nothing but reflective code. Okay, XS3 code is nothing but reflective code. Okay, and next you have sequential codes. Sequential codes. Sequential codes are nothing but each succeeding code, each succeeding code, uh, succeeding code, succeeding code is one greater than preceding code, one greater than the preceding code. Okay, so like 8421 and XS3 code. Okay, these are nothing but 8421 means what? Binary code you see. So this is 0000. What is the next bit? 0001. Okay, whatever the succeeding code is one greater than the preceding code. Okay, suppose next code you see 0010. Whatever the succeeding code, this is one greater than the preceding code. Okay, so like this. Suppose XS3 code also. So here XS3 code comes under the sequential codes. Okay, so here each succeeding code is one greater than the preceding code. Each succeeding code is one greater than the preceding code. Okay, that is nothing but sequential code. And so next, fifth one is alphanumeric codes. Alphanumeric codes. Okay, alphanumeric codes is nothing but you have ASCII codes. Okay, so this code which consists of both numbers and consists of both numbers, and alphabets, special characters. Okay, alphabet characters, alphabets. Okay, so ASCII is nothing but what? American standard code for information interchange. Information interchange. So that means here ASCII code is what? This is 7-bit, 7-bit in size. So in the laptop or desktop, you have keys, no? So capital letters and small letters. Okay. So here each and every letter, special symbol, special characters have a specific ASCII code. So what happens? Suppose A is pressed. Okay. Let us take A is let us example 41H is there. So 41 means so it is having 7-bit. This is nothing but 100, and it will be decoded like this 0001. Okay. So our processor will understand that. So you pressed capital A. So capital A means capital A pressed, and that will be decoded, and that will be processed, and that will be displayed on the display. Okay. So like this ASCII code will be there, and ABCD code. ABCD code means what? Extended binary coded decimal for information change. Okay, this is the extended binary BCD, binary coded decimal. Okay, this is also consist of both numbers and characters, numbers and character, ABCD code. Okay, and next you have uh, error detection and correction code. Error detection detection and correction codes. Error detection and correction codes are nothing but what? So you already seen like in communication. So you'll check the data whether you'll send some extra bits to for detection and correction of this code. No, so the data, so data bits, whatever the data bits, you'll send. Okay, along with the added added extra bit which allows error detection and correction. Okay, so which allows error detection, we are using for error detection and correction code. Okay, so like we have parity code, even parity and odd parity. Suppose you have 1011 is there. I want to find out the even parity. How many number of ones are there? So that four ones are there. So even number of ones means the even parity is 0. Okay. Suppose if it is 11010 is there. Odd number of ones are there. See here even number of ones means output is 1. Here odd number of ones means output is 0. Okay, like even parity, and Hamming code also. Hamming code is used for error detection and correction codes. Okay, so these are the codes you have. Okay, so like weighted codes, non-weighted codes, reflective codes, sequential codes, alphanumeric codes, ASCII. Okay, American Standard Code ASCII. Like alphanumeric codes, you have ASCII codes, and error detection and correction codes. Okay, and there is one more thing, like you want to convert binary to gray. Okay, and gray to binary. Okay, so binary to gray to binary, there is a conversion is there. So how to convert binary to gray code? So binary to gray code means here let us take one value like 1011 is there. Okay, so how we are doing? This is binary code. So how we are converting this value? So this is nothing but B0, B1, B2, and B3. So whatever this value is there, directly you take, and the adjacent you do XOR operation. Okay, binary to gray code. Okay, so here this XOR operation. So the 1 XOR 0 is means what? Here you are getting 1, and 1 XOR 0 is here you are getting 1. 1 XOR 1 is you are getting 0. Okay, this is gray code. This is a gray code for this binary representation. Okay, so in general I can write as what? G3 equal to B3, and G2 G2 equal to what? This is G3 G2 G1 and G0. Okay, G2 equal to what? B3 XR B2, and G1 equal to B2 XR B1, and G naught equal to what? B1 XOR B naught. Okay. Similarly, gray to binary, same value I will take. Okay. Gray value I will take 1100. Okay. This is G0, G1, G2, and G3. Okay. This is gray code. Okay. So directly whatever this one, this is binary. You take as it is. Diagonally, you need to do XOR operation. Okay. So here what you are getting, this is 1 XOR 1 means 0. Okay. Again 0 XOR 1, what you are getting 1. Okay. And 1 XOR 0, you are getting 1. Okay. This binary and this binary both are same. Okay. So that means if you consider this is B0, B1, B2, and B3. Okay. So I can say in general B3 equal to what? G3. B2 equal to B2 equal to what? B3 XOR of G2, and B1 equal to B2 XOR of G1, and B naught equal to B1 XOR of G naught. Okay. So this is how we can convert binary to gray and gray to binary. Okay. So today we discussed about this Boolean algebra. Okay. And Boolean laws. After that we have seen the Boolean algebra, and we seen some problems related to that. And next we have seen the codes, binary codes. Okay. So different types of binary codes we have seen, and next we have seen how to convert binary to gray and gray to binary. Okay. Yeah, is it fine? Any doubt in this? Give response.